Okay. Hello, everyone. Hope you can hear me. Today, I'll be telling you about something that came through practice, a very useful tool. By the way, for everyone who was here yesterday, today you get the premium version with my extra deep voice because I have since developed, I don't know, something. Probably because I fell asleep under the AC. Uh, but yeah, I'll be telling you about WasmCov, which is a tool that Bartosz and I created at Hacken, faced with a specific problem during a specific audit and wanting to generalize the solution. So a little bit about me. I'm an ex-Hacken security lead. I managed a team there, and I audited personally a ton of projects. I got out lucky because there's no hacks in my name. Other than that, I really like software testing, QA. I like fuzzers. Those are fun for me. I'm writing them mostly in Rust. I honestly think Solidity is not the greatest language. Rust is like my preferred one. Plus, they wear the best clothes, programming sucks. Other than that, I've done a lot of physics competitions, and mentoring students for those, which is like a fun side career. I like public transport. Belgrade is pretty nice in that aspect, and made WasmCov. So let's start. The first thing is like the problem with WASM coverage. But let's start with a quick poll. Who here is using WASM for anything? One? Okay. Who here has audited WASM or Rust code that compiles to WASM? Okay. Okay, obviously not as big of a market, huh? But you probably know these, right? So what do all of these have in common? They are all sort of L1s or L1 style kits, right? They're all written in Rust. They all have smart contracts written in Rust or Rust-like, and they all use WASM. But what they really have in common is the fact that you can write code using your standard developer process. You go to their official tutorial, whatever, you write some smart contracts. You can write code and you can test it, and you can get, using built-in Rust tooling, 100% test coverage, and everything seems to be working locally. And then you deploy that code, and suddenly you realize that, for example, your authentication function doesn't work at all. Like you cannot call it. It seems broken. So why? How is that possible? Well, let's take a look at the particular example where the inception of WasmCov happened on one near protocol audit. In short, near smart contracts, other than their ungodly JavaScript SDK, are generally written in Rust. And in Rust, you have macros, which you put to tag various things. They pretty much use WasmBindgen, which is like a Rust macro set that they modified a little bit, but that more or less creates WASM bindings for Rust code. And they also create some other cool macros for common functions like payable, for receiving funds. And on near protocol, they have like a fancy key structure where you have like main keys and like utility or function keys. They have some sort of weird access control scheme. And to get to the main key, you need to attach like one yoke to near, which is like a way to your transaction. And these macros are only triggered when compiling to WASM32, which means that when you wrote your normal unit tests, you were never really hitting these macros. And when you were writing your integration tests, well, you never really knew if you were hitting those macros. Because in general, coverage for WASM tests is not possible, it seems. And this is a real world example. This is a bug that was found manually on the Sweatcoin audit, which is a project that is so popular that it is hard coded in the near protocol node. Seriously. And we found the bug, and we were like, yeah, you should fix this, and you should add some integration tests, because the reason they missed this is because they didn't know that they missed the integration tests for this. But the question in my head was like, how do I fix this forever? How do I make sure this never, ever, ever, ever happens again to anyone else in the world, blah, blah, blah. And, you know, I think the solution is pretty obvious. You need to have test coverage for these integration tests. Right? It seems to not be that easy. You know, there's a ton of you guys here that are doing security and stuff. Blockchain has existed for nearly 2 decades now. Rust has existed for a while. And there's still, and WASM has sort of existed. There's some stuff about that is actually sort of the reason for this, and that's pretty much the fact that WASM is not very standardized, and last month we got file IO standardized. And that's the reason why, you know, a lot of stuff is gonna be broken for a while more. But yeah, it's in general not that easy. And to understand why it's not that easy, we need to take a short detour into something people are usually not going to be doing, and which is sort of the reason why this is not resolved. And that is that when people find an issue like this, they put 2 QA people on that problem, instead of, for example, digging through compiler internals and trying to find a fully automated solution. Because, you know, if you spend 200 hours automating something that takes 1 hour manually, it's not worth it. But I do stuff like that. I'm not optimal, right? So yeah, Rust compiler internals. I hope you've heard of LLVM. LLVM is the low-level virtual machine. Not really. It's like an old acronym that doesn't mean anything anymore, but used to mean something. And pretty much in the olden days, you know, when I was non-existent, you would be making an operating system or something on a new architecture, or on any architecture, and you would ship a compiler that goes from C code or whatever, or Fortran, to the architecture, so RISC or x86 or whatever. And that would just be like one step. And, you know, there were not that many languages, there was no need to be that optimal back then. But a while later, in the 90s, someone's like, let's make this a little bit better. And they created this thing called LLVM. LLVM is a front end for programming languages. Yeah. In short, you want to make a new programming language. IR is, by the way, the intermediate representation. You make a new programming language, let's call it D, which is a cool language with some very interesting features. And for it to be compatible with all the, you know, architectures that are already implemented, you just make the pathway from D to the LLVM IR. And now you support everything like x86, RISC-V, blah, 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 whatever you want, MIPS, take it all. Great, you're adding a new environment, a new virtual machine, say WASM, and all you need to do is go from the LLVM IR to WASM, okay? And that's it, it's way easier. And LLVM tooling is pretty strong in general, but it has some issues. Like one of those issues is that something in the step between here and WASM for Rust and for many other things that go through LLVM is just broken. And the reason for that, I would say, is the fact that WASM is very much non-standardized and that there's a gazillion runtimes. You know, WASMer, WASMe, WASMla, just make up a random word and put WAS at the start. And you'll get a new runtime. There's like a gazillion of them, right? So these are not, sort of the developer time is split just so that it's possible to make them all just barely work with just a few bugs, and there's no time for great developer experience. And that's how we got to WasmCov. But now I'm gonna pretend I was really, really smart and that I didn't spend like way too much time just slamming my head against the wall and finding the solution backwards. And let's just pretend that I had like a premonition, like, you know, Dune-like premonition of, yes, this is exactly what I'm going to do, and I'm going to be so wise and smart about it, and just have an idea of all the problems I'm going to face without actually facing them in practice. I mean, the facing them in practice was like a week and a half of part-time work, which is not too bad, but still, let's imagine I had, a spice melange premonition. So, thinking about how am I gonna get coverage to work on a WASM VM, which is custom, which is the problem that none of these VMs, that Near, Polkadot, none of these actually implement coverage in their VMs, and they're all actually a customized version of already a very custom WASM VM. I had to think about, okay, how am I even gonna find tooling that will allow me to do this? And for that, I took a step back and looked at what am I actually in. And I'm actually in a VM that lacks file rights, that lacks profilers, that's very, very, very constrained, and that also uses some domain-specific SDK. And to get an idea how I'm going to solve this, I just took a look at what tooling exists for a similar environment, bare metal environments. With no STD, with no profiler, with no file rights, etc. And looking at that and how that problem is solved, I figured out that we're going to have 3 steps. I can count 3 steps. Number 3, by the way, there represents unknown unknowns. So first, I need to somehow enable generation of code coverage and profiler data, so pretty much coverage instrumentation. 2, I need to get that out of the runtime because, again, no file rights, sort of limited, right? And very customized. And then finally, I just need to generate a human readable coverage report. And this was not that bad. So to start with, I only agreed to use Rust once coverage was sort of a feature that's stable. So I think that's like around 1.50, 1.40, something like that. So when this switched from Z to C. And that's pretty okay. So I just had to instrument coverage and add this no profiler runtime tag because this is a no profiler runtime. And this didn't take me 2 weeks to figure out. Okay, and that's okay. Now we have some instrumentation in the code that's generating coverage data, okay? It's just that we cannot get it out because normally it would just, write out some profile files because it would know that it's in an okay environment, but it doesn't feel safe with me here, okay? It's a no profiler runtime. So to get the data out, I looked up some tooling and I found MiniCov, which is made for embedded environments, which is like a Rust tool that actually scans the coverage, all profiler data that's generated, and it allows me to directly manipulate it, to capture it like this. The next step is to make like an extraction pathway. For a start, I'm gonna need to modify the generation pipeline for whatever blockchain I'm using to add something like this in there when the VM is shutting down. And then I'm gonna need to make a custom function or some random thing I can interact with, or I can write it into logs or into state if I'm crazy. It's honestly not that much data. It's just wonky, and get the coverage data out. And that's okay. This took a lot of time because it required to rework the whole code generation pipeline. And in this case, we were doing this for a test on Near protocol because that's what the audit was. And Near protocol was in the process of deprecating their version 4 SDK and moving their version 5. So I wrote the whole thing like 2.5 times as they were moving. So that cost me a lot of time, actually. And okay, after a lot of work, a lot of wondering what's going on here, a lot of problems with a mix of encodings that's happening for like communication within the VM because everything is ultra customized, right? And yeah, I managed to get the data out. I have a profile files, and it seems to be okay. It seems to contain some stuff. So I go and I use my magical tooling and I try to generate coverage data. I'm doing this because there's no documentation on what I'm trying to do, by the way. Zero, anywhere. And I try to do this and I get like no coverage data found. How is that possible? A week has passed. And there have been other audits, etc. And like, okay, what's going on here? Blah, 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 blah. In short, this is broken. So the coverage generation doesn't work because the WASM binary doesn't have the LLVM cov map data, which is needed by LLVM cov to generate the report. While debugging this, I learned to read intermediate representation fairly well, and to extract it, etc. And what we found out was that the IR was fine, so Rust to IR is fine, but IR to WASM is broken, that we have the cov map data there, and that I literally cannot dig through the LLVM compiler internals at this moment. It's going to take too much time. I submitted a bug to them. That was beginning of this year. And searched for a quick solution because, there's a ton of projects building multi-million projects here that really need coverage, that really need to have good developer tooling. Otherwise, they will get seriously hacked. And a solution was found. So the IR is fine. WASM is broken. What if we just cross-compile it? So we take the IR, we emit the IR here, and we use the tooling from LLVM to try to compile to, x86. And for like a really minimal program, it actually passes, and you get something that looks like a very, very small coverage report. So yeah, nice, win. A bit more testing, you figure out that it actually works only for the very, very minimal program that doesn't, for example, allocate memory. Because in WASM and in x86, surprise, surprise, memory allocation is very, very, very different. There's no pointers. For WASM, it's like memory grow and shrink. It's kids play. So this is sort of dumb, and another 2 weeks go by, and we figure out that, okay, we can just remove the WASM stuff, remove the WASM specific code. So we just stop that with unreachable all over the place, write a little regex for that. And now we have coverage working for everything, And if you want to read a bit more about this workaround, you can find information here or a Rickroll link, I don't know. And yeah, it's not done. It's not done whatsoever. So we just spent 2 months we got the method down, but getting it implemented for a specific blockchain in just Rust required an infinite amount of just tiny compatibility things from, figuring out, okay, which version of LLVM tooling should fit with which Rust version to I don't know, just managing the compiles to the regex and like modifications of the IR and then compiling the IR again. Like there was just 24 random tiny actions that needed to happen in the right order and that needed to be correctly done. And my idea here was, okay, this was a lot of work, but I want to make this easy to implement for others. And when I was younger, like about this tall, I was given a UX design book, and I read it, actually 2 books. And I was like, you know what? This thing needs more UX design. I was thinking, okay, what would be really, really beautiful? And what would be really beautiful is something that's like you just run this command and then you run your usual stuff and then you're fine. So I wrote this into a library and a binary that have pretty much the same usage, which is like setup, do your thing, finalize, that handle the compiled artifacts, the flags, the regex and the modification of everything. at the end of the day, you're compiling some binary and then you're running it in an integration test. So I gotta still respect your existing pipeline for what's happening with that binary. And tons of stuff like that. And there's also, the whole modifying any particular blockchain's VM or any VM this is gonna work on to actually support all of these things, patching just a gazillion things. So I want to make some of those also a little bit easier, at least providing, a standardized implementation for this function, for example. And I think I sort of achieved that. So right now the usage is something like this. This is the command line version. This is done like this because it spits out your Rust flag exports. There's tricky stuff about managing Rust flags within a CLI environment. Let's just say that, okay? And if I was setting them within this process, they would not be set. So I need to evaluate like this. Sorry, if you have a better solution, tell me. But other than that, you just build your contracts, you run your external tests, and you just finalize. And of course, you have to have a patched VM, which exists for a few things now. And I think it's pretty usable. Usage guide here, UX me is sort of okay with it. And you can see how it works for, let me just resolve the problem from yesterday. So this is a video demo, and it's not gonna open. This is not the video demo. Okay, nice thing about video demos is that you can cut out the compilation time. You just saw it jump to 170 instantly. So it generates the report, you can open the report, and you can see that you have all the standard stuff you'd expect, function line, region coverage. Because it's a bit of a workaround, it also gets all the dependencies coverage, but that's fine. You can filter those out manually or whatever you want. You can take a look at all the percentages, they're all shown correctly. You open your file, you can expect the coverage, and you can see what's happening here, in terms of is everything being called correctly. And yeah, I think that's pretty easy to use. This is for Radix, and for Radix, it's been sort of fully integrated. Well, there was like a full screen option, yeah. And in the meanwhile, I have left Hacken where this was created. Of course, leaving all the worst bugs for whoever's left there to implement. Just kidding, I'm not that mean. But yeah, and in the meanwhile, I've been following what's happening with this. So first we had Radix and Near because they wanted to support their developer community. But this has also been picked up by WasmBindgen and WasmPack for generating Wasm. So directly at that level. And it may actually come once again from the upstream back to various different projects. But I'm really proud recently to have also noticed. So in short, Docker, big containers, takes a while to boot up, like 30, 40, 50 seconds. Wasm workers with Kubernetes, pretty much instant, because you can have a hot virtual machine. So Cloudflare workers uses Wasm, and I noticed like in the repo activity that they are actually referencing our method and implementing them. Cloudflare now uses WasmCov. Theoretically, sorta, not quite directly. They're just stealing the code, but yeah, they vendored it, That's it for me. Thank you very much for listening, and let's go on to the Q&A.
Anybody has questions for Noah?
Yeah.
I'm not sure that the question makes sense. I'm not too deep into Rust. But I know that the Rust compiler also has some built-in intermediate language that's called Near. So have you considered doing this test coverage on the Rust intermediate language level?
The thing is, so Rust switched compilers fairly recently. It switched from whatever it was using before to using LLVM as the backend for everything. And also linker stuff. There's a ton of chaos there. Oh yeah, I forgot one tip. If this doesn't work for some reason, disable link time optimization. Like, you know how in network security it's always DNS? Here it's always link time optimization, I swear. Rust is now on LLVM, and I thought it was best to solve this where the actual issue is between LLVM and WASM. Because this also affects, I don't know, WASM programs written in C, you know, or in any language that you're really compiling to WASM through the LLVM. It's not just a Rust issue. I just wrote a library in Rust, and you can also use it in C, because Rust, you know. So that's pretty much it. Any other questions? Okay. Thank you, everyone.